talks. So in this lecture I will be talking about carbon cluster formation. Now the key to nanoparticle formation, there are certain rules. So when we're talking about nanoparticle formation, need to follow, there are certain keys. The first one is a high degree of supersaturation. And which is achieved in narrow time and space. The second one is suppression of aggregate. The nanoparticles formed, they can again form aggregate, and from nano the nano dimensions may be lost. So suppression of aggregation is one of the keys in nanoparticle formation. The third one is called monodispersed growth. Or you can also call it diffusion controlled growth. It means when the nanoparticle is formed, need to control its growth, and that growth can be controlled by controlling the diffusion, or there is a quantity called Ostwald ripening. I will tell you what it means in some of my later lectures. For the time being, just learn this quantity is called Ostwald ripening. So it is related to this diffusion controlled growth of nanoparticle. So these three are the key while nanoparticle formation. Now, as we will be talking about nanocluster formation, so nanoclusters were first found by a British chemist was Harry Kroto. He was the first to synthesize nanocarbon clusters. his instrument was something like this. Uh, what he did was he allowed uh, helium gas at 10 atmospheric pressure and he put a rotating graphite disc and he allowed laser to cause the vaporization. I'll call it as vaporization laser. Okay, so this was the schematic representation of his instrument. So he allowed the vaporization laser to fall onto this rotating carbon disc, and then he allowed helium gas. So ultimately what happened is that from here the graphitic or the carbon clusters were collected. Now here there was also a pulsed supersonic nozzle to generate the carbon cluster beam. The cluster beam. The vaporization laser was around 30 to 40 millijoules of energy it had. At the wavelength of the laser was 532 nanometers and the pulse was 5 nanosecond. This was the parameter of the laser beam that was used for vaporization. Now the role of the helium gas was it acted as it caused what we know as thermalization collisions. So it's necessary to do the cooling and the reaction for cluster formation. So what we actually get is we get a plasma due to this high laser beam we get a plasma, and to create the carbon cluster within cooling effect was required. That was done by this helium gas, and also it allowed the carbon cluster to be transferred at the edge, that means to the nozzle from where they have been prepared. Some medium was required to transfer them to the nozzle for collection. So that was also provided by this helium gas. Now this helium gas was also responsible for the supersonic beam that we talked about. And we had at the end a mass spectrometer for analysis. Now inside the carbon cluster, so when we analyze the carbon cluster, we got the evidence of the formation also inside the cluster. We saw that C60 has formed, which was quite stable. And the clusters actually had a tendency to react with other clusters formed. That means if we have a cluster formation here and cluster formation here and cluster formation here, so this is 1 and 2 and 3, so this will try to interact with each other. You have a tendency. So C60 was the predominant phase in the cluster formation. Now the energy of the helium gas is very important in this case. If we allow low energy helium gas, then apart from C60, some carbon fragments, variety of carbon fragments formation can take place. Now this C60 molecule, it is quite stable, so we just look into this C60 molecule formed. It was, as we have told, it is quite stable. It has got a high symmetry. I have discussed C60 molecule in my last class. It is like a shape of a football with carbon hexagons of carbon on its surface, and apart from these properties, the C60 molecule has it is relatively inert compared to other carbon fragments or other carbon compounds. It is less toxic. And the oxidation is difficult in this C60 molecule. Whereas it can undergo reduction and it can take up to 6 electrons. So it is basically an electron acceptor. Reduction is quite possible, and it can take 6 electrons. And the surface, it not only consists of carbon hexagons, but there are also pentagons, that is formation of 5 carbons. So if this is a hexagon formation, as we have seen in the graphene sheet, there are also formation of pentagons like this. So there are basically in the C60 molecule, there are basically 20 hexagons and 12 pentagons. They make up the C60 molecule.